Hello everyone and welcome back to my YouTube channel. So in this video, we're going to build the fashion recommender system using deep learning. So this is the demo application built by using Streamlight. So now if I click to browse files and we can choose the files from here. So let's choose these show images and it will load the images on our Streamlight applications. And based on this image, it will recommend me 5 images. That's been 5 similar images. So now if I actually click here to browse the images, so let's browse the images of t-shirt. So let's use this t-shirt, red one, and it will recommend me the 5 t-shirt based on this picture. That's been the similar picture of that. So this is one kind of recommended system. So in this video, we are going to build this one from the scratch. So this is the part number 1, and in this part we are going to discuss about that how can extract the feature of all the images. And the part number 2, we are going to test our model and also build this kind of application using Streamlight. So without any further ado, so let's get started. So in order to build the fashion recommender system, we actually using the deep learning technique. So for that, we actually using one pre-trained model that's called the ResNet 50 for extracting the feature of the images. So now let's see the architecture of the ResNet 50. So this is the architecture of the ResNet 50. So which one take one images of 224 cross 224 cross 3. And after taking the images, it actually extract all the feature. And finally, it actually give here the vector of 2048 features. So now let's see one example, how can you actually do that. So let's say we have one images of show. So we're going to pass this images inside our network. That's in our ResNet 50. So this image should be resized into 224 cross 224. That's been width, and the height of the image should be 224 cross 224. And obviously there should be RGB images. And after that, it actually give here 2048 feature vector. That's in one single feature vector. So if I actually assume that for the 6,000 images, so it will give here the 6,000 feature vector. Then we have the file length. That's mean we need the 2048 features with their corresponding file name. So if I am see it like that, so we have the 6,000 images. So we have the 6,000 feature vector, and also here the 6,000 file name with corresponding their feature vector. So how you actually try to test it out? So what do you do here? We need to just actually give here these same images as the input, one single images. We actually how you test it out? We just give here one single images that you see earlier. So it will go to this network, that's in ResNet 50, and this ResNet 50 actually give here one single vector of 2048. So we already actually extract the feature using ResNet 50 for the 6,000 images, let's say 6,000 images. So this 6,000 images vector is actually available on our pickle file. So now we are actually using the KNN to actually calculating the distance from each feature vector. So let's say we have one single feature vector, and we already actually extract the feature vector of the 6,000 images. So let's say this 6,000 image feature vector is actually available on here. Okay. So now if I actually try to put this feature vector on here, let's say this XU. So it actually calculate the Euclidean distance from the each feature vector with their corresponding feature vector. So it actually give here the nearest 5 images feature vector. Then using that, we actually get the file name also. Let's say this is the feature vector. You just pass here on the XU coordinate, and it actually taking the nearest 5 feature vector of the each images. So after that, this each images have one single file name, right? Because you already extract the feature and also their corresponding file name. So based on their file name, we are going to actually recommend here the 5 files of the images. Then you can actually show it on our screen. So in order to build the fashion recommendation system, we actually using one dataset from Kaggle that's called e-commerce product images. So if I go down, you can see here, this is the data. We have the 2 folder. So first folder, it containing the 2 folder that's called boys and the girls images. Okay. So it have nothing but 786 maybe images, 759 images are boys, and also have the images for the girls. Okay, you can see here on the girls. Okay, this is nothing but the apparels. It actually divides this data set like that. And also the images for the footwear. You can see here some of the images for the apparels, and also the footwear that's been the show. That's for man and the woman. So we just actually using this data set to actually baking one recommended system, which actually recommend here 5 images that you see earlier. So what we are going to actually do here, we are just going to actually download this data set, and after downloading the data set, we are going to take all the picture from the each images and combine it and actually store into one single folder. Okay, so now let's see how the folder structure look like. So I just downloaded the dataset and I'm taking all the picture from the each folder, and I am creating another folder that's called dataset and just passed here the files. Okay. So they are nothing but 2,906 images maybe. If I actually check this out, Control A and go to the properties of the all images, and I can show, I can see here, you can see here 2,906 images here. So just you need to create one folder like dataset, and you need to actually paste here all the images. Okay. So now I'm going to open my Jupyter notebook. So let's say JUPYTR notebook. You can also use here the Visual Studio Code because I am doing some feature extraction part. So that's why I prefer you can use the Jupyter notebook. Okay. So now I am click here to create new Python file here. So let's say Python 3. And I'm going to go on the full screen mode. It's better. So let's give here one name. Let's call feature extraction. Okay. So for the feature extraction, we actually using the ResNet 15. You can actually using your own CNN model to actually extract the feature. So now we are going to actually extracting the feature using ResNet 50. So for that, what I'm going to do, first we are going to import here the TensorFlow. We need here the TensorFlow. And we need the Keras also, because this ResNet 50 module is actually available in the Keras, and this is one transfer learning technique. So first we import here TensorFlow. Then what did you do? We need to import from Keras dot. So we need one ResNet 50, right? So it's available on the Keras dot applications. Okay, it available in the Keras applications dot ResNet 50. Okay, so applications dot ResNet 50. We are going to import here ResNet 50. Enter. Okay, and it will actually import here in our kernel. Let's increase the size. Okay, so now what we need to do here, we need to actually initialize here our model. So for that, what we're going to do, we actually using our ResNet 50, which is actually using one word that's called the ImageNet. So now I am going to actually create one instance for our model. So let's say ResNet 50, and inside that I am going to actually initialize here the weight of the ResNet 50. So it's actually using the weights of the ImageNet. So let's say ImageNet. Then we need to actually initialize here the include top should be false, because we actually train our model in our own data set. That means we are going to extract the feature using our own data set, and ResNet 50 is already trained on some data set. So we are going to actually not taking the input layer here. So let's say include top filter, that's the top one, that's in the input shape. We are going to actually make it false. That's mean you don't need the top layer of the ResNet 50. We are going to actually give here our own top filter. Then we need to give here our input shape, that's in our target size. So let's say input shape equal to 224 cross 224. As you see earlier, when I discussed about the ResNet 50 architecture, you see it will actually take the input shape as 224 cross 224 cross 3. So it will also give it 3. So this is nothing but our channel. Then it's better you can actually store into one variable that's called model. So let's say model equal to ResNet 50, weights is nothing but ImageNet, and include top should be false because we actually give here our own data set. And input shape is nothing but our 224 cross 224 cross 3. Then we need to also make our model trainable should be false, because this is already trained in some data set. So now we need to make our trainable should be false. Enter. Okay, so it will take few seconds. If you're doing it first time, it will actually download this ResNet 50 from the internet. Make sure you connect the internet. So now let's see the model summary. Okay, so if I see the model summary, if I go down, this is so big, ResNet 50. You can see here it actually give here 2048. Okay, feature vector. So now we need to convert it into one single vector of 2048. But you can see here none 7 cross 7 cross 2048. So what I can do, you can actually use here the max pooling layer. So for that, we need to also import here the Keras dot. So this max pooling is actually available inside our layers. We actually import here the max pooling. So max pooling 2D. Okay. So enter and enter and enter. Okay. So our model is actually initialized here. So now what I can do, we can actually add the max pooling layer after the model. So what I can do, you can actually using our TensorFlow here. So let's say model equal to TensorFlow dot. This is available inside the Keras. So you're actually using the sequential model. So let's say sequential. And inside the sequential, we are just going to actually add our model and our max pooling 2D layer. So let's say max pooling 2D. Okay, this one. Enter. So it will actually give here the value. But we got one error also. So this is not kind of error. That means we have to change this max pooling layer because it give here none 33 and 2048. So this is not one single vector. So you need to just make here into one single vector. So whereas the max pooling 2D is not giving here. So for that, we actually using the global max pooling 2D. So it will actually give here one single channels. Okay. If I actually now run the code, and if I see the model summary, I can give here just none and the 2048 feature. So now we can actually use this model to actually extract the feature from our images. Cool. So now what we're going to do, we need to also load the images. Okay. So now you are going to test it out for one single images. And after that, you are going to actually load all the images from our dataset folder. So now what I'm going to do, I am going to actually first load one single images, and I am trying to extract the feature using the model. Then I'm going to define one function which will actually extract the feature, and it will actually store into one single NumPy array or a pickle file, and also the file name, right? So what I'm going to do here, I am going to actually load here one simple images. Well, so now what I need to do, we need to actually import here the CB2. So import CB2, this is OpenCB library. So now we are going to actually load the image. Let's say image equal to cb2.imread. So the image name is 1636.jpg. Well, so if I try to show it, let's say cb2.imshow, and I can give here one window name. So let's say frame and the image. Well, and also give here one wait key. So let's say wait key, this one, and also give here 0. So enter, and it will actually open here one images. Well, you can see here one images. This is quite big as you load it here. So now what do we do? We load our image correctly. So now we need to pre-processing these whole images based on our ResNet 50 model. Well, so it will actually load here the images. So now what did you do? We need to actually, using these images, we need to actually extract the feature from the images. So for that, what I'm going to do here? So we are going to actually convert this image into one NumPy array. Okay. So let's say image. So we need to also import here the NumPy array. Okay. So let's say import NumPy as NP. So let's say import NumPy as NP. After converting this image into NumPy array, so what we're going to do here, we are going to actually reshape the images based on our model. And ResNet 50 is nothing but one CNN model, so we need to also expand the dimension of that. So let's say, so how can you convert this image into NumPy array? So just you actually use here image equal to image dot, not image dot, actually np dot array and image. Cool. So now if I am see here image dot shape, so I can give here, I can get here the shape of the images. So this is our shape of the images, have 3 channels. That means this is nothing but called RGB images. So we need the 224 cross 224 cross 3 size of images. So it is not compatible for this model. So we need to also resize it. Like, so let's say cb2 dot resize, and we need to actually give here our image name. So let's say this is our image. And we need to give here our width and the height of the images. So let's say 224 cross 224, right? So now if I see the shape of the images, this is nothing but 224 cross 224 cross 3. So now our input shape is ready. Cool. So now we need to actually expand the dimension. That's we need to reshape them. So we need to reshape them based on our images. So that should be like that. Number of images. That's mean number of images. So this is nothing but of number of images of batch of images and your weight. So let's say 24 and your height and your number of channels. So you need to actually make this kind of reshaping of the images, okay, to actually train up the model. Okay, let's extract the feature. So now I am going to actually comment out these lines. So for that, we can actually using the np.expand dimensions from the numpy. So let's say np.expand dimension. So this is called expand dimes. So if I am going to actually give here our image and the axis should be 0, let's assign into one variable that's called expand, let's say image. If I run the code and if I'm trying to see the shape of our expand dimes, and you can see here 1 comma 224 224 cross 3. So this one is nothing but one images because we load just one images. So this is for single images. But if you load the 2906 images, so it will actually look like that: 296 images cross 24 cross 224 cross 3. So expand dimensions. So now we need to actually process this input from the ResNet 50. So for that, we need to also load here our process input. So let's say process input. So this process input is nothing but the processing input for the ResNet 50, right? So for that, okay, process input for Keras layer is not actually available. I think you need to actually give it on here. So let's say process input. Okay, this should be not process, it actually pre-process input. So just we need to actually copy this and we are going to actually use this pre-process input, and we need to give here this expand dimension images, and we need to also store into one variable. So let's say these our pre-processing images. So let's say pre-processed image, okay, or you can say let's say pre-image, like that. Enter. Okay, so now if I am feed the pre-image, so this is nothing but one array. If I am trying to see the shape, and you can see this shape and this shape is always same, and it's just pre-processing the image based on our model. Now we can actually predict our model here. So to do that, we actually using the model dot predict. So just we actually using this predict function to actually predict our images. So just copy this, and I'm going to assign into one variable. So that's called result. So it actually processes image. So if I show the result here, so let's say result, and it will give here one array. If I'm trying to actually show the shape of the array, so this shape of the array is nothing but one for one single images, and 2048, this is nothing but a feature of the images. Well, so we get the feature of all the images here. That's one single images. So if I have the 2096 images, so we got the 2096 images feature vector one by one. Well, so now what we need to do, we need to also make this predicted should be flattened. Okay. So now if I can show it, you can see here we just got here 2048 vector. That's mean we don't have any batch of the images right now. Just we have the images of feature vector. Okay. Well, so now we need to also make it normalize so that we can actually get here one single value. So if I am trying to show the result, you can see here this value is not actually normalized. Okay. So we need to also normalize them. So for that, we can actually using one norm function from the numpy. So let's say from numpy dot, this is from the linalog. So let's say linalog. We actually import here the norm. So this is nothing but the norm function. So no module name numpy dot linalog. So I think I have error. So let's say linalog, yep, linalg, that's not linalog. So let's say we are actually using this norm function to actually normalize this whole result, right? So for that, what I'm going to do, we are going to divide this result with our norm of the result. So let's say norm of the whole result. Then it will actually give here one normalized vector. Well, so if I am trying to actually store into one variable, that's called normalized, and let's actually try to see the shape of that. So let's say shape. So shape is nothing but 2048. So now it is normalized. Okay, so this is nothing but the pre-processing of the images. So now you're going to do this part of all the images, and then you're going to actually store these the feature extraction part into one file and with their corresponding file name. Well, so now we are defining one function. So let's say def extract feature. So which one taking one image path, so and also one model. That means this model here. Okay. So now what I'm gonna do, we are going to just copy this and paste it here. Okay. First we are going to actually load the images. So let's say image path, just give here image path, and then what we're gonna do, we are going to convert this image into numpy array. So let's say np.array. Then we are going to actually reshaping it. So let's say reshaping it. Well, then we are going to pre-process that. So just pre-process that. Then we are going to actually predict it, and after that we are going to normalize that. Okay, just actually going to normalize that, this normalize one. Well, then we are going to return here this normalize. Well, so now if I actually run this and try to actually call this function here, so let's say call the function, we need to give here one images. So let's say give here 1636.jpg and also our model. So this is our model. Well, so we get here one normalized array. So now what we're going to do here, after extracting all the feature from the images, and we are going to actually calculating the equivalent distance, and based on the equivalent distance we actually command the 5 images, right? So our feature extraction part is done here. So now we need to do this feature extraction part for all the images. So for that, what we're going to do, we are going to actually define one functions. Already we defined one function that's called extract feature. So now we are going to actually extract here, we are going to actually define here one list for file name. So here you actually store the file name, and another list for the feature list. So which have the feature list that's been vector of 2048. So let's say feature list. So this is called feature list. Okay, well, so now we are going to actually load our images. For load our images, we need to also import here the OS, right? So now we are going to actually take all the images from our directory. So for that, let's say for file in os.listed, that's when we are going to actually create one list of our whole directory. That's our data set. That's our directory. Then we are going to actually joining all the images with their path. So let's say os.path.join, just join them based on our data set. That's mean this data set, and with their file name. So there should be the file. Well, then what we're going to do here, we are going to actually store inside our file name. So for that, we are going to just append it. Well, and then we are going to close it here. Okay, now if I am run the code, it will take few seconds, right? Okay, well, it will actually done. So if I am trying to show the file name, so let's say file name, and you can see here all the images is come. Okay, if I am trying to show the first 5, let's say 0 to 5, you can see here 5 file name is appeared on here. Well, now when we do the same thing for the feature list, this means extract the feature from all the images. So for that, we need to do the same thing for that. So let's say for the feature list, so let's say for file in, let's say file name. Okay, for file name, That's mean this file name. We are going to actually extract all the files. Then what we're gonna do, we are going to extract the feature, right? So for that, we need to call this feature extraction, this method, and we need to give here the file name. So there should be the file and also our model. Then we need to store into inside the feature list, right? So let's say feature list dot append, and also here. Well, then we can actually, what I can do, we can also show the, what do you call, show the processing. So let's say we can actually using here TQDM to actually show the processing of that. So we can just using this TQDM so that we can actually see that how the processing actually looks like. So just actually using this TQDM and enter. So TQDM is not defined. We need to also run the shell here, and we need to just run the shell. Okay. So you can see here the processing of that in a bar, and you can see we have 2,906 images. So it takes few seconds to actually extract all the features. Then what we need to do here, we need to also store into one pickle file. Well, so our feature extraction part is done here. So now we need to also store it. So for storing it, we are going to actually using the pickle. So let's say import pickle. Then we are going to actually save it here. Let's say pickle.dump, and we are going to give here the feature list. That means this feature list, and also the file name. So let's say this should be the file name, and you're going to actually save it in the write mode. So let's say feature vector.pickle file and file name.pickle file. Just actually run the code here, and it actually store into our directory, right? So now you can see here two files is generated. One is a feature vector.pickle file. We have the feature list and also have the file names that they are corresponding file names also. So using these files, you can also test it our model that our model actually working here fine or not. So this is all about this feature extraction part. This is the part number 1. And in the part number 2, you are going to test it out and also try to build the web application if possible. So this is all about the whole tutorial. So I hope you enjoy this tutorial, and make sure to subscribe my channel. Also support my YouTube channel also, and do subscribe this always and share with your friends. So I'll be back with another tutorial. So till then, take care and bye bye.